We are back, and once again, Dr. Oscar Rodriguez with the Electronics and Technology Fundamentals course. We have covered so far part one and all four lectures, and we did one lecture on part two. This is the second lecture actually on part two we're doing, and later on we're going to cover once again part three, part four, and part five of this course. So let's go into today's lecture. Which is essentially lecture number 6, understanding electrical power sources or circuits. This is a little more in-depth explanation regarding electrical power sources and circuits. And so the fundamentals here is the fact that we need to be able to identify the components that form a basic electrical circuit. On the left-hand side, I have a very basic electrical circuit. You can see it. On the right hand side, I have the schematic circuit for the basic electrical circuits. And we're going to study all the components in detail. Sometimes when you study basic electrical circuits, there's a part that we have here that is not included. However you want to see it, and is the control of the circuit, which is this guy right here, which is the switch. All right, we're going to go into the lecture, and we will just say that a basic electrical circuit is made out of 3 elements. Also, complex circuits will have these 3 elements, and those 3 elements you will always encounter in a basic electrical circuit, no matter what. It's number 1, the power source, which is this guy right here, right, the battery in this case. The electrical conductors, which are the guys that conduct the electrons and protons. The electrical resistance or the load, which in this case is the light. And then of course you got a switch here, which is part but not exactly. The circuit could work without the switch as long as the circuit's closed. That's the reason why sometimes the switch it's or not included. So however you want to see it, I'll just say that there are 3 elements required for any electrical circuit: power supply, electrical conductors, and electrical load or resistance. Some important concept here when you're dealing with electrical circuit is that in all circuit the ampere hour rating is an important consideration. We're going to dive into that a little bit. And also the kilowatt hour is the measure of energy consumption that we pay to the energy company. All right, let's go in detail over each one of these components. The power sources could be of 2 forms essentially: a direct current power supply or an alternate current power supply. I'm showing you here a power supply that provides us both. That provides us in the left hand side AC, and on the right hand side DC. So you could have a power supply, such as in this case, that provides you alternating current and DC current. But we also talked in our previous lecture that many times a battery or a form of battery becomes the power supplies or the storage device. And there's numerous applications of portable devices where a battery is the main source of supply. Now, power supplies like this one are typically used in laboratories, in factories, or in places where you do electrical circuits work. And so this is an example of a DC-AC power supply. All right, that's the backbone or the main part of the electrical circuit. Right? Now, in addition to that, we also said that the electrical circuit has conductors, and under that category of conductors, you can say a lot about conductors once again, but the essence of it is that good materials to manufacture conductors are gold, copper, aluminum, and of course they're talking to them about superconductors. Of course, you won't see a lot of gold-based conductors. Why is that? Because they will not be there in the post. They'll be taken away. Copper is also used in some applications, but not heavily as aluminum is. Aluminum actually is the prime material for electrical conductors. Now, there are some applications where you still use copper. For instance, computer contacts and other special contacts will use special varnishing of gold. And because gold makes an excellent conductor, That's the reason why it's used. Of course, it's expensive. You cannot use it in all applications. So it is limited to just a few special applications. But aluminum will be the prevalent type of material. And then they talk about superconductors today. The whole idea of superconductors and conductors in general is how do we create a system that doesn't waste energy in the transportation of that energy? Because there's a lot of waste of energy or voltage and current when you transport energy because of the heat dissipated, because of the resistance, and so on and so forth. But just keep in mind, electrical conductors are made of materials that are able to conduct as freely as possible electrons and protons from one side to another. Okay. Um, in terms of the electrical load of a circuit, we have broken down the circuit, which consists of power supply, conductors, and loads. You could have electrical loads that are what you call inductive or AC, or you could have electrical loads that are DC. Um, Both are the general types of loads that you'll have in a circuit, electrical circuit or electronic circuit. In our case, I'm looking at a motor here. That'll be an AC load. There's also pilot lights in here, which are considered loads also. Those will be loads, and those loads could be DC or AC loads also. I also have a heating element, which makes out another type of load. That load can be, again, a DC or AC load. But in any case, the idea here is that a load is the device that do work. In other words, if I have the power source and I have the cables, but there's no load, I'll be wasting energy, right? Because the energy that I have in my source and that is being transmitted through the conductor is not being used. And so you want to play a load or place a load so you can obtain some work. Um, for instance, if I have a motor, that motor will be coupled to a mechanical machine that will do some work. Let's just imagine that you have a mill to prepare um, food for cattle or something like that. And if the prime mover is the motor, it'll be fed by the cables that come from the source, so you can transmit that power onto a mechanical system that will do the work. In the case of the lights, of course, illumination is the purpose of light, and so voltage and cables will conduct the electrons that will make the lights light. All right. And in the case of the heating element, this could be a washing machine, this could be a dryer, or anything like that. In any case, is a load, and that load is there to be able to do some work. The whole purpose of any load is to provide some work. Okay. So let's talk a little bit about battery-rated situations here. Let's just say that we have a power supply based on a limited storage device, which is a battery, and the rating of that battery is 200 milliamp hour. And that particular 200 milliamp hour battery supply can supply 5 milliamp of power or current for a number of 40 hours. How do I figure that out? Easy. 200 milliamp hour divided by 5 milliamp, which is the required power or current. When you divide that, is 40 hours. You could also have the same situation where the 200 milliamp hour storage device provides 10 milliamps instead. So at 10 milliamps, the battery storage device will only last 20 hours. This is a normal or what you will call extraordinary circumstances. And finally, the third example will be if I have that same 200 milliamp hour device, storage device, and I want to draw 20 milliamp of power, I can only use that device without recharging for 10 hours. You see how easy the math is? All right, so that's what we call battery rating. Okay, the other concept is amp hour or kilowatt. All right, let's say you have a battery that's rated at 50 amp hour, and it must last for 5 days. The question here is what kind of current can be drawn from the circuit or that storage device. And so the answer is 10 amp hour per day, or 0.417 hour amp per hour, or you could also say 417 milliamp per hour. How do we get that? Well, 50 amp hour divided by 5 days, that gives 10 amp hour per day, or better yet, You divide the 50 amp hour by 120 hours, which is 5 days, right? Did I do that right? 5 days. No, that's wrong. That's the wrong number. So forgive me for that. I'll have to make that correction. So the second is not exactly right. Um, 5 days will be, no, that's right. That's perfect. So this will also be another valid answer. Let's just say 50 amp hour divided by 10 days. That'll give me 5 amp per day, or the same as divided at 50 amp hour by 240 hours, which provides me 0.208 amp per hour, or you could also say 208 milliamp per hour. Okay, so those are ratings that you also need to keep in mind, basic math, when you're dealing with battery storage devices which have limited life and limited supply capability. All right. So let's review what we discussed so far here. Power sources, batteries have limitations in terms of lifetime and storage capacity. We talked about conductors, and we said gold, silver, copper, aluminum, and superconductors are good conductors. Primarily aluminum is used, superconductors are being used today, and silver and gold is used for some special application. We talked about electrical load or resistance, and we said that motor, lights, and heating devices are the type of, you know, workloads that you may have that you require to do some work. And then finally, we talked about the fact that in all circuits, the ampere hour rating is an important consideration. Kilowatt hour is measure of energy consumption, and we made some calculations which you should be able to actually do them. All right. So this is the end of lecture number 6. Dr. Oscar Rodriguez. I will see you next time in our next lecture when you come back. All right. Thank you. Have a great day.